Shlok Jain, and welcome to the GeekyAnts talk show, the place where a bunch of friends gather together and discuss on certain topics, right? So, in this week, for our first pilot episode, I'm joined by my beloved colleagues. We have Shivam, Prabhat, and Aditya, and we'll be discussing on database design, right? So, welcome, guys. Welcome to the first pilot of the GeekyAnts talk show. So, yeah, hi. All right. So cool. So database design, right? So I'm sure what all of us are aware what database is, right? We have already studied like in 4 years of engineering. But designing of database is certain thing that we need to have, a better insight on, better expertise on. Because I've learned that once you start to build product, and once you're responsible for a product, there's a lot of things. As the product increases, there are many dependencies which come along. And only if you have a good database design, it can be more efficient, more effective, and it becomes much more beautiful. The product excels much more better, right? So let's start with it. Cool. So what is database design, right? That's the fundamental first question. So Prabhat, would you like to tell us what is database design?
So database design is more or less having your entity sorted and planning it in a way that how you'll be storing your data in the database, more or less. The better you design it in terms of how you can query it easily and have more views attached around it and things around enhancement of the data that you're storing.
Yes.
That is mostly around the database design system. Database designs is pretty much like the core of every web app that we see nowadays.
Okay.
Any application you build or website that you build, data is something that you need to have. Their relationships need to be defined very uniquely, differently, and how are they related
so correlation of database, because it helps to fast retrieval, right? But there are a lot more importance to databases, right? So can we jump a bit more into importance of why database designing is important?
So as I said, it's not always about storing it. It's also about retrieving it fastly.
Yeah.
If you have a very poor database design, at one point in your product journey, there will be a point where you will face lots of trouble querying the data itself. So whenever we are designing, we need to take care of all these aspects so that in terms of scalability, in terms of querying it, in terms of fetching it, and what properties do you need in terms of what entities should be defined at the top level and their relationships, right?
Yeah.
So that's where it plays a very vital role.
So I think so it also helps so it increases performance basically, right? The better correlated the data is, it is increased performance because we can fetch things faster. Also, I think so it helps in cost effectiveness. Because in the long run, we can store data more efficiently.
Correct.
Right?
If you have a very poor database design, there will be a huge chances that you have some redundant data and some data which is not properly correlated. So you'll have to fire multiple queries to fetch same amount of data but in different queries.
So this can also lead to data inconsistency.
Correct.
Right?
Yes.
So hence database designing is important. Awesome. So we know what database is. So let's not jump into like the nitty-gritty and basics of it. But there are two types of databases, right? Shivam, so would you like to take up from there? So if we're dating this, we understand what database designing is. Now on what type of databases, what type of designs we would implement.
So like two big databases which are categorized are SQL and NoSQL. So SQL is basically your structured database, right? You know in your entities what are going to be your attributes and how you're going to map it both logically and physically, right? You know your ER diagrams, your relationships with every other table. So you have your SQL in that way.
Okay.
NoSQL is basically when you're not sure what your data is going to look like inside an entity and you don't know how it's going to scale. Like you don't know your column names, what are they going to be. So we keep such kind of data in NoSQL format, which is basically a JSON or key value, those kind of things. And coming to the importance of it, when to choose what, right? So SQL, when you are going to scale your data vertically, right? So every data increase row by row, right? And their relationships with different entities also increase row by row. So that is vertically
scaling of database. Yeah.
And with NoSQL, it is horizontally scaling with the key pair value or your JSON, which is basically a document of data.
Essentially, you have the fixed columns that you have in SQL. Yes. That is something you always know that these properties will be related to
always
this entity in my. But with the other NoSQL approach, what happens? You can have random columns coming in from certain. Suppose you have third-party APIs that you are calling. So there will be random API responses that might come in, correct? So you can just have a normal generic key value pair in terms of say some third-party API response, and you can store that complete object under the hood. without having to define the schema of it. So that's where it comes a bit handy in terms of storing.
Okay. So, but as you told in NoSQL, we're not defining schema, right? But does it like suppose as we told, we can also store JSON object in text long. We can store it in relational databases as well.
Yes.
But storing a JSON object in relational database and storing a JSON object in NoSQL, is there difference in performance?
Yes. So when you have it in a MongoDB, your JSON data is directly queryable even inside a nested object.
Okay.
But not all of the relational database allow you to do that. For example, if I'm not wrong, in MySQL you can't even have that JSON block column. You can't even query on
You have to get it in parse it.
But you have it in Postgres. In Postgres, you can actually query a column and inside that a key.
Yeah, exactly.
But querying in that way happens quite faster in the NoSQL databases.
Yes. Okay. So database designing, right? So once we have understood what are the development life cycles of a database, right? So obviously we have to implement these designs, right? So what are the various development life cycle? What are the steps that takes place for the entire, from the plan inception till the end of a database designing?
It starts with resource planning.
Yeah.
So it starts with resource planning. You gather the requirements, right? So planning and system definition. So basically, you need to before an application developed and you just start with the database. You have to start with like how it's going to come together, right?
Correct.
Which entities or tables or basically what data you're going to collect.
Correct. Any real world object that you have in your product. So suppose I'm an e-commerce company. So whatever products that now I'm gonna have, whatever cart individual is gonna have. So you have to have all that definition first, and then based on so suppose what your client needs when your request response structure is being made, right? So you need to have all those things during the first phase of it, where you decide everything.
So first phase is mostly brainstorming and gathering what sort of information we're going to be having,
and their relationships,
what type it will be, so what kind of relationships we can establish based, and once we have what kind of relationship we have to establish, we have to go into a bit more, which is like the system part where we have logical and physical models, right? And logical model is where on surfacially it's a paper design essentially, right? Where we design what type of data we'll be querying. Like it's like a view, but it's a virtual setting, virtual relation of a
It's
database.
more like having a complete blueprint of what entities will have, which entity will have what attributes, and their relationships between them. But they, as of now, we have nothing physical connected with it. It's just on paper.
Then we have logical model where it's mostly on pen and paper, right? Where we define what sort of relationships we'll have based on our requirements, obviously. The similar data can be stored in various different forms based on how we want to query it and make it more effective. So that again, database designing aspect comes into this, right? So then we have the physical model of it. So would you like to take that, Shiv?
Yeah, physical is the storage of the actual logical.
Actual implementation
using foreign keys, primary keys, and constraints like indexing, those kind of things. And that can be different from your logical design, but it's quite similar to that.
Okay. Okay. Awesome. So let's coming to implementation. There's one certain thing which we have, common. A key thing which people often miss out and don't really understand its value, indexing, right? So Prabhat, would you like to tell why indexing is important, and if you have any fun anecdotes, which I'm sure you have to share with it?
Indexing is really critical. So in nowadays, with whichever application you choose, you might be using PhonePe more than, I'm not sure if I'm allowed to take names, but so you might be using PhonePe more than GPay. The very obvious reason is because it's fast. So nowadays applications, we want everybody, all the users are concerned with the speed and how accurate the data is coming, how quickly it is coming, right? So indexing plays a really important part in it. And indexing is more like you, so suppose you have 10 lakh records, what you do, you create an index in one of the attributes, and then those 10 lakh, that particular attribute has an index created. And whenever you query on that index, that particular query is not searched in all the records, it's just searched in that attribute field.
Yes, so it exponentially increases the search speed, right?
Search speed is increased by a lot. You can have single indexes and you can have multiple composite indexes as well, wherein you have a mix of two different attributes in the same table, or a JSON doc that we call object in NoSQL. So you can create both single and composite indexes. So one quick thing that happened during our development cycle, we had like 10 lakh records in one of the projects. And we had written a recommendation engine where you suppose we do have some preferences mapped. And if I say that I'm a backpacker, you are a backpacker, so we get a score of 4. He's not a backpacker, so he'll get a score of 2. So that's how we had a recommendation engine built. And in that, we had to query one of the tables from those 10 lakh records, and we had to fetch some data.
Okay.
And that used to take around 15 to 17 seconds every time.
Okay.
And we created a couple of indexes, if I'm not wrong, and we queried on that, and our response time came down to around 4 or 5 seconds. So it was two-third of efficiency. So a great thing to have it in your database every time you are any get query you are writing, you write it on either on your primary key or you create an index for it.
Yeah. So
Best.
I kind of felt like people kind of miss out on indexing. So that's a fun story to remember. Hope next time when you guys are designing your database, you will make sure to include indexing properly. Awesome. So let's come and talk about a bit of glossaries for database design, right? So entity. So the other day I was discussing with a friend and I'm like, I asked, bro, what is entity? And the guy said entity is table. And then the people around him started to laugh like, bro, entity is not table. But he's like, technically it is table. Speaking in terms of RDBMS, entity you consider as table.
Correct.
But that is not what it is, right? Yeah. I think so. You guys looked up what entity is on Google, is it?
So more or less, it's a table. But
that is in context of RDBMS.
Correct.
Because of the software, yes, it is a table. But speaking of in terms of design perspective, what exactly is an entity?
Entity is anything that any real world object that you will be needing in your product or your website or anything. Anything that has a real world existence has to be an entity.
Exactly.
And every time you have an entity, you have certain properties associated with it,
and
hence people often confuse entities too.
So
there could be some attributes in the entity which you don't probably want to store, or you have it but you don't really need it somewhere.
Exactly.
So in that sense, it is a bit different, but yeah.
So entity is a real world object, but when we have to convert it to an electronic form, it takes the shape of a table. Basically. But you cannot go and say next time someone asks you, hey, what is entity? You can't say, hey, it's table. So that would be wrong. So attributes are basically the properties of the entity, right?
Each entity.
Awesome. Good. So normalization is something we often learn. 1NF, 2NF, 3NF, BCNF, and I'm sure all of us had to mug up these definitions for those 5-mark answers in our examinations. But speaking of normalization, why is it important? And Shivam, can you just give us a brief gist of an example? You can take an example and just walk us through a normalization.
You can consider a large database, like a very large database, and first of all, why is normalization important on that database? Like querying and using indexes also sometimes is not
good enough.
Right? It won't be efficient if your data, you have inconsistent data, redundant data. Okay, and that is also on a single entity. If it's a single entity storing too much data and you're querying each time on the table, it's not required there, right?
Okay.
So you need to break down those tables.
So you're saying horizontal scaling is not a good option? Is that what you're trying to say?
I mean, in SQL you can't always query on some things which are not indexed first of all, and you don't usually go there every time. So that's why normalization is important, to reduce the redundant data and break down larger chunks of data.
Good, awesome. Yeah. So we have relationships in relational database as well, right? So could you please walk us through relationships, the various forms of relationships for primary key, foreign key, and just walk us through why is it important with examples, just to explain.
So whenever you have an application, you always have a complete flow of data, right? Yeah. User is gonna come in from here. We'll have his email ID and name and stuff, and then he will go to my next page, maybe landing page, any other page. So there is always this flow of data which you want to have it, which generally you have it in the database because you have to cater them next time, correct? So relationships are more or less. Let's take a quick example. Suppose GeekyAnts. We have a bunch of around 500 employees nowadays. So how we handle all of the data about all the employees in a single, it can't happen, right? So for example, I have some degree from somewhere, my educational details has to be in certain other table. My salary details might be in some other table. My personal details information would be in some other table. Having everything in one particular entity is not really possible.
Okay.
Right. And so let's
that again that also is a good example for normalization, right? Like suppose if we have a candidate table and candidate has its address and everything, we will not store candidate address everything in the same table. We'll create another table and then we'll have a foreign key relationship.
Also in this case you will have one-to-many relationship.
Yeah.
Which is
cardinality, right? Cardinality 1 to 1, 1 to n, m to n. Yeah, awesome. So could you please tell us more about cardinality? And relationships, basically.
So each individual each entity what you are calling, each table that always has a primary key. Based on that, we query that. We know that this particular record is a unique one in this particular table overall, right? And suppose I have 4 records as of now in my users table. So all of us having 1, 2, 3, 4 primary keys, that is a subject. You can have it in a different format as well, but sequentially suppose. So now my educational details is I have another table where I'll be assigned this particular ID, a foreign key for main users table or employees table, right? So this is how you keep mapping or keep a track of each entity as they grow up. So employees, and then another table, educational employees educational qualification, employee
being the foreign key.
Personal details, So you just keep the track of foreign IDs over here, and and you also have some ORMs where you can directly query all the foreign keys and everything in a single go. So you query for user and you also get everything attached to it. That happens when you type in your model, when you design your model. So that's I think about it.
Yeah, good, awesome. So I think one more thing, a key aspect is our database is transaction handling, right? So can we discuss on transaction handling of databases? How does that work? How do we handle transactions with
transaction is basically
a series of steps.
In terms of any read-write operation that's going on around your DB, which is a very critical operation. So let's take a quick example. Suppose I have PhonePe and I want to pay you 5,000 rupees as of now.
Okay.
So the first step, I open my app, everything loads up, all good. I search for your number, type in 5,000 and start sending it. So as soon as request goes in, there will be multiple DB calls that will happen at the back end of PhonePe, correct? What will happen? They'll create a transaction ID, payment ID maybe, then the source from where it is going, the target where it is going, the time when the transaction was initiated and whatnot. There'll be multiple DB queries running at the background, and also you have to deduct 5,000 from my account and you have to credit it your accounts, correct? So what happens? A transaction basically helps us do a series of steps, step by step, and if any of the step in the middle fails,
we roll back.
Everything is rolled back.
Yeah.
So suppose first instance was to get a transaction ID for me and deduct my money, and the third step was to credit money in his account. Suppose first and second happened and it wasn't credited to his account. So in that case, transaction will fail, and the debit which has happened from my account will be again rolled back to plus 5,000, and the transaction ID which probably would have a different status maybe or something. So everything that you have, wherever it failed, everything before that goes back to the original state.
This kind of reminds me, so recently I wanted to buy a sneaker. There was this Jordan drop, and I was like, on the site I was trying to click buy. I even wrote a Python script which would keep on, buying, hit the buy button to get that shoe. But then so in the back end, if you wonder, obviously at one instant there are thousands of queries that are coming for one particular product, right? So in this case, we have online transaction protocol, right? OLTP. So what this does is, this does not, exactly. So this takes cues from the asset properties, right? Isolation. So all the queries, though they're coming simultaneously, they are converted in a sequence format, right? Where the only one is getting served and all the ones are offloaded to the client. So the client can come and retry again. It's not like a queue where server takes a load and server is trying to retry. So that's also another type of transaction which is quite fun to know about. So all the online shoppers who keep trying to buy the latest drops, that's how it works. Awesome. So speaking about online shopping and transactions, which I do a lot, I like to think considering e-commerce site, there's so many transactions happening, there's so much of data that's there, there's so much of data that's being queried. It's obviously an amazing system, very well designed, right? But how does it happen on the server side, right? So I would like considering load balancing and scaling, when there is when there's a drop, a major drop, or a festive season is coming up. So obviously the load on the site is going to increase dramatically, right? So how does load balancing and scaling come into play? Obviously, guilty shoppers like us.
Hotstar, right? 1.34 million.
Exactly. So when there is heavy load on the database, how would we handle scaling and load balancing?
So basically, load balancing and scaling is an important term that we need to discuss when it comes to designing a DB infra. So basically, load balancing is of two types. One is a layer 7 network load balancer. That load balances your incoming request to your database instances based on the read-write requests. And then there is another load balancer that is a classic load balancer. That means transfers the read-write request on the instances based on the CPU and RAM usage.
Okay.
So, and after load balancing,
scaling.
One major thing is scaling.
Yeah, because when it's dramatic, because obviously we're not going to have so much of system available to us at all time, because there'll be a lot of unused system which will be paid for, right? So it has to be effectively used. So scaling is a major part. So we have vertical and horizontal
and vertical scaling.
Yeah.
So vertical scaling, what we do is basically we shift from a smaller system onto a larger system that has better resources, so that it can handle multiple read-write requests at a time as per our requirement.
Okay.
So what is the best way to do it? So what we do is we create one small, that we have one initial server on which the database is running. So what we do is we get a bigger server with more power. We connect it to the server using a master-slave architecture and transfer the data via live replication onto it. And once all the data has moved on to the larger server, we gracefully bring the smaller server offline and establish the connection to the bigger server.
Okay.
So this is...
How is this different from upscaling and downscaling? We have vertical and horizontal, fine, but how is it different from upscaling and
upscaling, downscaling is a different concept. As in upscaling we increase the number of instances, and downscaling we reduce the number of instances. That is that is for cost effectiveness, as to bring down the cost by not having unnecessary number of instances running. So before that, there's something known as horizontal scaling, as we were talking. So horizontal scaling can be easily understood with something known as sharding. We have it in MongoDB, NoSQL databases. So sharding is what we do is we divide a particular database into separate chunks and store it at different places. So, but sharding requires a lot of expertise. If you are able to manage it, it's a very good technique. But if you are not, then your performance is going to take a serious hit. So, and also load balancing. See, in load balancing scaling, what we are doing is we are simply increasing the number of instances, and downscaling we are reducing the number of read-write instances. But we also need to maintain data availability and consistency in this case. As in, and how do we have consistent data and available data at various available regions? That is replication. So replication basically is of three major types. One being master-slave replication, where at minimum you need two servers. One is a master server, one is a slave server. You can have multiple slave and master servers as per your requirement. Write can only take place on the master server, whereas read can take place on both master and slave servers. And advantage of it is live replication. When we establish a master-slave architecture, the data that is being written on master at that point of time only, it's getting replicated on the slave. So consistency of data is maintained throughout the entire infrastructure. And another point is we can have, since write is not happening on slave, we can create live backups directly from the slave server. So backup is a good strategy, can be easily implemented in terms of master-slave architecture. Then there is another type of replication that comes in, that is master-master architecture. But master-master architecture is difficult to implement, and the problem with it is data consistency. Because write might be happening on multiple master servers at a time. So data consistency might be an issue. Then there is one new term that has come up, I was reading about, it's not very popular, is group replication. It has better fault-tolerant replication technologies. So what happens is there are a number of servers. At one point of time, they elect one server out of the entire cluster, and only on that particular server the write can happen. So this is group replication. It's not very widely used, it's still under development, but can be handy in later stages if the development of that particular strategy is very good.
Wow, that's really insightful, Aditya. Thank you so much. Speaking of replication and databases and inconsistency, I think so, Prabhat, there was a story where you told me once regarding getting the database back, which you had. Would you like to share? Would you like to give us insight as to how this architecture actually helps us in production scenarios, right?
Right. So I'm not going to tell you the entire story, but if something goes wrong, you can always go back in real time, 15 minutes back or half an hour. It depends on how you have taken up the backup, how you have scheduled it.
Right.
Generally, it is recommended that you have it in less than 24 hours, so that you lose at least amount of data that you try to preserve all the data. That's all. And I lost about 5 days of data, I think. But yeah.
So how was the process, like the retrieving of, how efficient is it?
It is generally provided by your cloud service provider.
Yeah,
so what happens is you have your server and you create a backup of it. I guess it's called mirror or something, image or something. You schedule it. When do you want to schedule it? And it automatically gets created and it is stored in one of the buckets. You decide where. And whenever you have any sort of data inconsistency that has happened or something blew up or something, you just take that backup and start working on that.
I think this is an important thing because people need to learn about this when they're heading into a production scenario.
And one more point I'd like to add in this is, for example, the master-slave architecture. How the backup can be restored. Suppose the master slave goes down, what we can do is simply select one of the slave servers, promote it to being a master, and then that restore has happened.
In master slave, can we have a number of? Suppose
you can. Depends upon your requirement and the number of data.
And can this be in different regions?
Yeah, it can be. Yeah.
So that way, it's again a great point, right?
Yeah.
For different users.
Availability
across
across
and
exactly.
And latency also.
I think so. This is deployed by all the major streaming services, right? Because across the globe, that's how they do. They'll have a major master server where they will deploy the latest copy, and that is used to provide to all the other places.
Right.
Yeah. Awesome. That's been really insightful, guys. Awesome. So thank you guys for joining. So I hope all of you enjoyed our first episode, and we discussed a lot on database designing thanks to these geeks that have joined us. So we learned what exactly database designing, what's the importance, the life cycle, its glossaries, the transaction protocols, inconsistency, scaling, and load balancing. And it's been fun. And thank you guys for joining. Thank you guys for joining in, having us. And we'll be back shortly, probably next week with another tech show and another talk show on another fun topic with a fun few people. So thank you, Aditya, Prabhat, and Shivam. So I'm your host, Shlok, and signing off. See ya. Bye-bye.